So here's a concave mirror. So this is the shiny side over here. So imagine we took a light source. Let's say we sent in a beam of light like this. It's going to reflect off the mirror. Now what direction do you think it's going to reflect? Up, down, or right back from where it came from? So remember, if we draw on the normal, our normal, because of a curved mirror, would look like this. And so our reflection should be on the opposite side of the normal at the same angle. So this would reflect down. Likewise, if we sent one down here from the bottom, okay, our normal's now shifted, and this is going to reflect up, like that. I'm just sending a couple more beams. This would come in, reflect like this. Come in, reflect this. What happens if I send it right down the middle of the mirror? So that it hits right on the normal. Well, it's just going to reflect straight on back. So one thing you should notice is all these 5 parallel beams I sent in, when they reflected, they all kind of reflected towards one single point. And all 5 of these beams will intersect right at a single point here. And this point is what we call, you've heard this term before, the focus or the focal point. So all those 5 beams, or a million beams, however many beams you send, any parallel beams that you send in are all going to focus together at a single point. We call that the focal point. Okay? Now you've probably maybe not played with these type of mirrors before, but you've probably done this with a magnifying glass. And a magnifying glass has the same kind of effect, where you can take light from the sun, for example, and you can focus all of that into a single point. Right? And then you can burn stuff if you wish. So that's the same effect. This would be our focal point of a lens, and we'll get into those later, but for a concave mirror, this all comes together right here. Okay? All right, another point we're going to look at is this. This is a part of a circle. What if I continued the circle? So if I continue the circle, I would have a center to that circle. And that center would have a radius. Which we'd call the center of curvature or the radius of curvature. That radius would be the distance from the mirror to here. The focal length would be the distance from the focal point to the mirror. And there turns out to be a very nice relationship. And I didn't draw it perfect, but maybe close enough. What's the relationship between the radius and the center? It's exactly 1/2. Yeah, so the radius and the focal point. So the radius of curvature, we'll just call this C, is exactly twice the focal length. So if you have a focal length of 10 centimeters, the radius or center of curvature would be 20 centimeters. So it's exactly double. Okay?